All right, so let's continue off where we left regarding adding forces. Okay, so what do we call a force as? It's the rate of change of momentum because we can define it as mv minus mu over t, and mv minus mu is the change in momentum divided by time becomes the rate of change of momentum. So we are going to learn how to add two or more vectors by drawing and how to add two perpendicular vectors by calculations as well, because we know that forces are vectors, and this means that measuring their magnitude is important, but equally important is knowing the direction in which they act as well. In order to calculate the overall effect of the multiple forces acting on the same object, we can use the vector addition method to find out the resultant force, and this resultant force can be considered as a single force that has the same effect as all of the individual forces combined. For example, two forces acting in the same line, 11 Newton and 7 Newton. Now, if they are in the same direction, we're going to add them up and it becomes 18 Newton resultant. But what if they are opposite in direction? 7 Newton acts on the left, and on the right we have 11 and 4 Newton acting. So now it's gonna be 11 plus 4 is what? 15 on the right and 7 on the left. So 15 minus 7 would give you 8, and the resultant would be towards the right direction because 15 was the greater number. The effect of an object of two forces that are acting at right angles perpendicular to each other will be the vector sum of their individual effects. We need to add the sizes with considerations for their direction in order to find the resultant. So if we look at the magnitude of the resultant force, to calculate the resultant magnitude of two perpendicular forces, we can draw them one after the other as the two sides of a right angle triangle. Use Pythagoras theorem to calculate. जैसे हमारे पास one of the force is, let's say, acting over here of 5 Newton and the other is acting upward, okay, which is 70 Newton. So we can make a vector by using the head to tail rule. Start with any vector, and this is going to be your resultant, which is basically the hypotenuse. So you can use the Pythagoras maths theorem over here to find the resultant force as well. Let's do another example. If I say this is an object and there's a force acting over here, which is of 4 Newton, and there's a downward force acting, which is of 5 Newton. How do I make a triangle? Start from any vector. Let's say you want to start from 4. All right, we'll start from 4. I'll draw a line like this, which was exactly like 4. And now where am I going to draw this 5? I'll connect the head to the tail of 5 like this, and then this would be your resultant force that you're going to find. So adding the two non-perpendicular forces, what if they're non-perpendicular now? Now we are going to use the angles. Because it's not always, compulsory that it's always going to be a 90-degree angle. The geometry of perpendicular vector makes the calculation of the resultant simple. We can find the resultant of any two vectors by drawing one after the other, and then the resultant will be the third side of the triangle from the start of the first one to the end of the second. A scale drawing of the vector triangle will allow the measurement of size and direction of a resultant. So here you can see by looking at this scale drawing, we can find the angle as well by using a protractor, and then we can find the resultant as well. Then there's the parallelogram rule as well. There's another method for finding the resultant. Like if we had two forces acting like this, their middle line is always going to be the resultant. वो आप निकाल सकते हैं. But what I did was I joined both the vectors by head to tail method, and then I found the resultant, which is the same thing as this. This resultant is also in that direction, and this resultant is also in the same direction. We call it the parallelogram rule. And I can make a parallelogram easily. अगर ये आपके पास दो forces हैं like this, you get the same force can be in front of it over here, and the same force can be in front of the other one. So it's basically the same. Both the angles would going to be the equal as well. We call it the parallelogram rule. And draw the two vectors to scale at a correct angle at scale, so their length represents the magnitude starting from the same point. And the diagonal thingy would be your resultant. Now, what are free body force diagrams? If we clarify what forces are acting on an object, it can be simpler to calculate how it will move. To do this, we usually draw a free body force diagram which has object isolated and all the forces that act on it drawn in at the points where they act. Now the forces acting on other objects and those other, for example, figure number G is a free body diagram of a rugby player. Now its resultant would be the middle line, and for that you'll have to find the angle as well to find the resultant. So resultant force is the total force acting on a body when all the forces are added together according to the direction. So we can call resultant force as the overall force acting. Free body force diagram showing an object isolated and all the forces that act on it are drawn and at the points where they act using the arrows to represent the forces. Moving on, moments. Moment of a force क्या होता है? We're going to calculate the moment of a force. How do we apply the principle of moments and how do we find the center of gravity of an object? Forces on an object could act so that the object does not start to move along, but instead rotates about a fixed pivot. If the object is fixed so that it cannot rotate, it's going to bend. So moment of force is the force multiplied by the distance. Okay, it is the force into the product of the distance. It's the product of force and distance, you can say. Two in the line of the pivot. If this is the pivot and this is the force that is acting clockwise, this would be its distance that we are going to use. So moment is measured in Newton meter, which is force multiplied by the perpendicular distance from the pivot to the line of the action of the force. Here you can see this point is what? A point is always present in any object. It can be called as the center of mass, or you can also call it center of gravity. And how do we define it? It's the point where all the weight of an object seems to be acting upon. And if we add up all the forces acting on an object and the resultant force, it's going to be zero. We say that the body is in equilibrium. There are always two conditions for equilibrium. And what are those two conditions? The first condition is that the resultant force sum would always be zero. And the second is that the resultant moment sum would always be zero, meaning that the anti-clockwise moment would be equal to the clockwise moments. So the principle of moments tells us that if the total of all the moments trying to turn an object clockwise is equal to the total of all moments trying to turn an object clockwise, then it will be in rotational equilibrium. This means it will either remain stationary, or if it is already rotating, it will continue at the same speed or the direction. But remember to take all of the clockwise movements and the anti-clockwise movements in the same direction. Okay? So here you can see, if we want to write down the equation, first find out which of the forces are clockwise and which of them are anti-clockwise. So W naught is clockwise and W2 is clockwise. So W naught multiplied by X naught plus W2 multiplied by X2 equal to the anti-clockwise moment, which is W1 multiplied by its distance x1. Exactly the equation that is written over here. You would be given the values of all the weights and distances, and one of them would be unknown. For example, over here, W naught was unknown. The weight of an object is caused by the gravitational attraction between the Earth and each particle contained within the object. The sum of all these tiny weight forces appear to be acting from a single point for an object, and this point is known as the center of gravity. For a symmetrical object, we can calculate the position of its center of gravity, and it must lie on every line of symmetry. The point of intersection of all lines of symmetry will always be known as center of gravity. If it's for a regular object or for an irregular object, you can just find the center of gravity by using a plumb line method as well. एक plumb line method होता है where you can hang the object and different direction and keep rotating it. Keep drawing the lines where the plumb line is actually intersecting, and that intersection point will be known as the center of gravity. Here's the center of gravity, equal amounts of mass, the point where all of the weight of an object actually seems to act. So for irregular object, I told you you can use a plumb line method. Okay, you can see a video about what is a plumb line method, but the center of gravity of an irregularly shaped object will still follow the rule that it is the point at which its weight appears to act on the object. A Bunsen burner, for example, has a very heavy base as such, and the center of gravity is low down there, the concentration of the mass. Now, if you look at a Bunsen burner, okay, you can see this base is very much concentrated with the mass. Then why is it not tipping over? Because the center of gravity is very much concentrated in the base. If it was concentrated over here, then obviously it's going to tip over. It's always going to tip over to the side where there is a center of mass. Newton's laws of motion. If we kind of overview all the three laws of Newton, we can discuss the first law, that an object will remain at rest and will keep moving with a constant velocity and zero acceleration until or unless an external force is applied on it. That is your Newton's first law. Newton's second law क्या कहता है? That when a force is applied, the object is going to change its velocity and it would accelerate, which is also is equal to F is equal to ma. That force is the product of mass and acceleration, or you can say it's the rate of change of momentum. These are both known as the second laws of motion. Third law क्या कहता है? That for every action, there's going to be a reaction force. If an object A applies an equal and opposite force on object B will also apply an equal and opposite force on object A. If you're pushing the wall is going to push you as well. So if an object is stationary, if we talk about Newton's first law, if an object is stationary, there needs to be a resultant force on it to make it move. We saw how to calculate the resultant forces in section 1a.3, and if the object is already moving, then it will continue to move at the same speed in the same direction until a resultant force acts on it. And if there is no resultant force on an object, we say that its motion has not changed and it's going to remain in equilibrium. Whereas Newton's second law अब क्या कहता है? This law tells us how much an object's motion will be changed now if we do apply a unbalanced resultant force. For an object with constant mass, it is going to change its motion by accelerating. And why? Because we have applied a certain force. So for example, this relationship allows us to calculate the acceleration due to gravity as well. And from this, we can find two relations. That force is directly proportional to acceleration and acceleration is inversely proportional to mass. If I increase the force, acceleration would increase. If I decrease the force, acceleration will also decrease. This is a directly proportional relation. But inversely proportional kya hai? That if I increase the mass, acceleration would go the opposite. It's going to decrease if the object is heavier. And if the object is lighter, having a lesser mass, acceleration is going to increase. So Newton's third law of motion क्या कहता है? When an object A causes a force on another object B, but then object B can also cause an equal force in the opposite direction to act upon object A. For example, when a skateboarder pushes off from a wall, they exert a force on the wall with their hand, and at the same time, the wall exerts a force on the skateboarder's hand as well. This is an equal and opposite reaction force as well. इसी तरह के आपके पास अर्थ के ऊपर भी है. When you are walking on earth, when you're standing on earth, the earth is also applying an equal and opposite force on you. Huge mass ho ya aapka mass ho, it doesn't matter. If you're applying a 70 kg mass on the earth and if you're applying 700 Newton weight on the earth will apply equal 700 Newton force on you as well. So these are the summary written for all the first, second, and third law of Newton, which are very important to remember as it can be asked in the form of definitions as well. Moving on to the equations of kinematics, we have discussed about the simplest formulas, how to calculate the speed, distance, and acceleration, and how do we use the speed time graph and distance time graph. But now you're going to be introduced with some new equations. We call them equations of motion as well. Kinematics is the study of movement of objects, and we can use these equations to find out the details about the motion of objects accelerating in one direction. Zero acceleration का क्या मतलब है? That the velocity or the speed is going to be constant. If an object has no resultant force, it would have zero acceleration. But if it's going to have an unbalanced force, balanced forces का मतलब है resultant force is zero. Unbalanced forces mean that there is a resultant force, there is a force, and there will be an acceleration, either an acceleration or a deceleration. This is known as a uniform motion when we say that there is no resultant force and zero acceleration. Calculations are very easy. You can easily calculate the velocity by distance over time. And the velocity is the same in the beginning and also at the end of the motion. So there is no changing in the average or the instantaneous velocity. And if we need to find the displacement traveled, you can obviously do distance is equal to speed into time. Constant acceleration means what? When there is constant acceleration, now you're going to discuss about the different equations of motions that you have to consider because now acceleration is involved. And acceleration is going to be involved in all of those four equation of motion. There are equations that allow us to work out the motion of an object that is moving with a constant acceleration. And for these kinematics equation, we have to know that S is displacement, U is initial velocity, V is final velocity, A is acceleration, and T represents time. And it depends that which equation of motion that you have to use in which equation. How will you know that? By the data given. let's say what data are you given, and then see that which formula is fitting all of the data that is given to you. If you are given the acceleration, speed, initial speed, and final speed, you have to use an equation of motion that does not include time because you are not given time in the data. By rearranging the equation that defined acceleration, we can come to know that if A was V minus U over T, and if you want to make V the subject, take T over there, multiply it with acceleration, and take U over there as well. So it becomes V is equal to U plus AT. This is your first equation of motion that you have to remember. For example, if a stone is dropped off the cliff and takes 3 seconds to hit the ground, what is its speed when it does hit the ground? So identify the three things that we know. Acceleration when it's under free fall concept. Free fall may we have studied that the acceleration is going to be when weight is the only acting force. 9.81 will be your acceleration, which means a constant acceleration. So yes, kinematic equation can then be used when we have a constant acceleration. If it's starting at rest, its u would be 0. Time given was 3 seconds. You can find the final speed easily by using the first equation of motion u plus at. Because it started from rest, u would automatically be 0. So you can just use v is equal to at as well. Just multiply 9.81 with the time taken. It took 3 seconds. Simple as that. You don't have to include u because it was already at rest. Distance from average speed कैसे निकाल सकते हैं? Now, as the kinematics equation only work with uniform acceleration as we have seen, the average speed during any acceleration will be halfway from the initial velocity to the final velocity. Therefore, the distance traveled is the average speed multiplied by the time. Now, how do you find average speed? It is initial speed, final speed divided by 2 to find the average, and you have to multiply this average speed with time. This is your second equation of motion that you have to remember. And this is a very rare one though. The first one is very common, and now we are going to do two more after this as well. So it again depends on the data that what you are given, and you can put in all the values in the second equation of motion and find it. The third equation of motion that you have to remember is S is equal to ut plus half at squared. This is your third and the very important equation of motion. And again, the second one, अगर हम बात करें, this is the fourth one. And this is the fourth equation of motion. You don't have to go through all of these derivations that how were these equations actually derived. You just have to memorize the four equations of motion, which are V is equal to U plus AT, V plus U divided by 2 into T. Okay, this one. Then S is equal to UT plus half AT square. And then the fourth one is V square is equal to U square plus 2AS. The third and fourth ones are actually very, very important. So which quantity is absent in all of these, and how are you going to know which one do you have to use in the question? If distance is not given in the question, you can use this one. If acceleration is not given in the question, use this one. If there is no final velocity in the question, use this one. And if you are not given the time value in the question, you can use this one because this equation doesn't involve time. So kinematics is the study of the description of the motion of the objects, and uniform motion किसको कहते हैं when there is no acceleration. And you have already talked about the four equation of motion that you have to write down in your copy and are very, very important in all of our upcoming topics as well. Now comes a very important part, which is resolving vectors. We are going to talk about a very new concept, which is components. How do we resolve the vectors using their components, and what are these components? How can we find the resultant force by using these components? How many types of components are there, and what is it actually? We have seen that vectors that act perpendicular to each other can be also combined to produce a single vector that has the same effect as the two separate vectors. If we start with a single vector, we can find a pair of vectors at right angles to each other that would combine to give a simple original vector. We call it resolution, which is the reverse process. Reverse process क्या होता है? How did you find the resultant? You were given two vectors and you found the resultant. Now the thing is, you are given the resultant and you are going to make its two vectors. We call it resolution or making components. First, you were given vectors, vector 1, vector 2, and you found the resultant vector. Now you are given the resultant vector and we are going to find its two vectors, the horizontal one and the vertical one. Every resultant, every force has two types of component. We call them, one of them is known as the horizontal component, and the other one is known as the vertical component. Now let's solve by resolving these vector calculations. In order to resolve a vector into a pair at right angles, we must know all the details of the original vector. This means we must know its size and the direction is the most commonly given as an angle to either the vertical or the horizontal, and this is useful. Now, if you look at this, that we have 4.2 meter per second vector given at an angle of 40. We can make its two components, that this vector has a horizontal component as well, and this vector has a vertical component as well. Now, what is the value of the vertical component? We can find it. How are we going to write it? The resultant force sine theta. This is the formula for finding the vertical component. And for horizontal component, we're going to do F cos theta, which means what is the vertical component? 4.2 sine 40, and horizontal component would be 4.2 cos 40. This is how you find the vertical and the horizontal component of any force, any speed, any vector that is given to you. It's not basically force always. Now, this is a vector of speed, and speed also had two components because this resultant did arrive from somewhere. How was this resultant made? ये बनी कहाँ से थी? From a vertical component and from a horizontal component. तो यहाँ से we can calculate two types of component. Now this was 4.2 given, ठीक है? Now what did you do? Finding the vertical component of velocity. Redrawing the components in figure V to show how they add up to produce the 4.2 meter per second. The velocity vector shows again they form a right angle triangle. This means we can use the relationship. So can I say that if I want to find the vertical component, now what is the formula? Force is always V x over Vy. ठीक है, याद रखिए. It's always x over y. So I can say कि Vy over 4.2 is equal to cos 40. And if you want to find Vy, it's gonna be 4.2 cos 40. तो ये आपको Vy आ जाएगा. और आपके पास हॉरिजॉन्टल कंपोनेंट अभी आ जाएगा साइन से. इट डिपेंड्स, ठीक है, व्हाट डायरेक्शन आर दे टॉकिंग अबाउट. इफ दे आर कॉलिंग दिस द वर्टिकल कंपोनेंट, देन यू हैव टू यूज कॉज. रिमेंबर, फॉर अ स्ट्रेट लाइन हॉरिजॉन्टल के लिए हमेशा कॉज यूज करेंगे, विच इज अवे फ्रॉम द एंगल. एंड द लाइन विच इज इन फ्रंट ऑफ द एंगल, रिमेंबर दैट अगर ये वाली जो लाइन है, इफ इट्स द ऑपोजिट टू द एंगल, ठीक है, इट्स गोना बी ऑलवेज साइन. ये देखिए एक लर्निंग टिप आपको देता हूँ. डोंट जस्ट रिमेंबर कि हमेशा ये जो स्ट्रेट वाली लाइन होगी इट्स ऑलवेज गोना बी साइन. इट्स रॉन्ग. इट्स नॉट ऑलवेज साइन. इट डजंट मीन दैट ऑलवेज द हॉरिजॉन्टल लाइन इज कॉस. इट्स एक्चुअली व्हाट, साइन थीटा इज ऑलवेज द ऑपोजिट वन, ठीक है, विच इज द ऑपोजिट, विच इज इन फ्रंट ऑफ द एंगल. द लाइन विच इज इन फ्रंट ऑफ द एंगल वुड बी साइन, ठीक है. Then the adjacent one, ठीक है, which is this one, is going to be the cos, and you already know between the right angle and the angle is gonna be tan. So whatever you are given, let's say आपको दिया हुआ है, you are given this force which is 5.6. You want to find this one, you can do what? 5.6 cos angle which is Q. And if you want to find this one, now this is a horizontal line. Horizontal line doesn't mean it's cos. It can be sine because it is front of the angle. आप देखो एंगल कौन सा यूज कर रहे हो. इफ द एंगल वाज ओवर हियर देन दिस साइड वुड बी द साइन. तो हम ये वाली साइड, ये वाला वेक्टर कैसे निकालेंगे? 5.6 साइन क्यू. Alternative resolution of angles. If we know the velocity of an object, we have seen that we can resolve this into a pair of velocity vectors at right angles to each other. Now, the choice of the direction of right angle pair though is arbitrary and can be chosen. Now, this is the velocity. It is going in this direction. Now, I can draw two vectors of this velocity. Okay, I can draw a horizontal vector as well, and I can draw vertical. एक मैं यहाँ पे line डाल देता हूँ, ठीक है? And the other line I'm going to draw is like this. This was the velocity vector, and it has two components, component 1, component 2. Now, which one of these is the horizontal component and which one of these is the vertical component? Let's see. 45 डिग्री एंगल है, यहाँ पे 45 डिग्री डाल दें, ठीक है. एंगल के सामने कौन सी लाइन है? एंगल के सामने दिस लाइन है, सो दिस इज गोइंग टू बी साइन एंड द अदर वन इज गोइंग टू बी द कॉज. और ये तो आपके पास रिजल्टेंट है. ठीक है, so you were given the resultant, and from resultant you have taken out two components. So how are you going to find this one and this one? ये मैं निकाल लूंगा, like what is the velocity given? V sin 45 and cos, वो क्या हो जाएगा? V cos 45 for the other component. Look at this. एक हो गया V cos 45 and the other one is V sin 45 आपके पास आ जाएगा. ओके, ये भी क्लियर है. सो जस्ट रिमेंबर, जो हमेशा आपके पास एंगल के सामने, दैट इज गोइंग टू बी साइन, एंड दी वन विच इज बिटवीन द एंगल एंड दी एंगल, वो आपके पास कॉज हो जाएगा. ठीक है, डोंट एवर थिंक कि सर ने कहा था कि वर्टिकल हमेशा साइन होता है, दैट इज नॉट ट्रू. ठीक है. So resolution or resolving vectors is the determination of a pair of vectors at right angles to each other that sums to give the single vector that they were actually resolved from. Catapult क्या होता है? It's a device that can throw objects at a high speed. और इस catapult को भी अभी हम study करेंगे in your next topic as well, which is the projectiles. Okay. Now, what are projectiles? Projectiles, you can see, is a trajectory motion. Projectiles क्या होता है? It is a trajectory motion. Objects thrown or fired through the air generally follow the projectile motion. It doesn't mean that if you throw a ball like this, it's always gonna go straight for the rest of its life. Obviously, it's going to take a trajectory path and it is going to, fall this much distance, but it's not gonna come directly, or it's not gonna come straight for the rest of the life. It's gonna follow a very curved parabolic type of a path. Okay? If you try to throw a ball to a fielder, if you throw this direction, it doesn't mean that the object will keep going in this direction for the rest of the life. It's gonna fall one day or the other at a very curved path. It's gonna fall once or other. So that parabolic pathway, or that particular curved pathway that any object thrown takes on its way, we call it a projectile motion. So what is a projectile motion? उसको देखते हैं आगे. Here we are going to combine ideas from the various earliest sections in order to solve questions about projectiles. Resolving vectors showed that the action in each of the two perpendicular directions are wholly dependent, and this means we can use Newton's laws of motion and kinematics equations separately to look at the same object's two types of motion. We only consider the motion after an object projecting has actually caused it. So all vertical motions are going to follow kinematics equation, which give gravity as the acceleration, जिसके अंदर हम यहाँ भी 9.81 ही यहाँ पे यूज करेंगे. Horizontal throws की बात करें, if an object is thrown horizontally, it will start off with zero vertical velocity. याद रखें, हमारे पास ये एक parabolic path है. This is the cliff that you were standing on. At the very start, there will be a horizontal velocity. A horizontal velocity will always be there, but the vertical velocity at the very initial position is always going to be zero, because you never threw the ball downwards. It went downwards afterwards when you threw it horizontal. याद रखें. So the stone is kicked off horizontally off a cliff with a horizontal velocity of 8.2. How much time is the stone in the flight, and how far does it get away from the cliff by the time it actually lands? Now, horizontal and vertical motions are totally independent, and here the vertical component of velocity is initially zero, but the stone accelerates under gravity, and uniform acceleration means that the kinematics equations can be used over here as well. Now, the time taken to the hit, आपको सारा कुछ data दिया हुआ है. What do you have to calculate? You have to calculate the time that is taken. We know that u was 0, a is minus 9.81 because it is coming down. तो ये क्या हो जाएगा? Towards the gravity, minus 9.81 coming down है, ठीक है. And the height fallen was minus 60 because its displacement can be vector, and it has a minus direction. So you can use the formula S is equal to ut plus half at square. You can remove this ut because ut is equal to 0, क्योंकि आपके पास इनिशियल वेलोसिटी वाज आल्सो 0. पीछे क्या रह गया फॉर्मूला? S is equal to half at square. Put in the values, make t the subject. Making t the subject gives this formula, and this is the value of your t. So horizontally, there is no accelerating force once the stone is in the flight, and it has a constant speed. तो अगर आपने horizontal distance निकालना है, you can multiply the horizontal speed with the time. अब हॉरिजॉन्टल स्पीड आपने यू कैन इजिली कैलकुलेट कि हॉरिजॉन्टल स्पीड तो आपको दी हुई थी विच इज 8.2. So you can multiply 8.2 with the time that was there in your answer. But remember one thing that is very, very important. Whenever you have to calculate uh, the vertical velocity, you always use the vertical distance. And when you have to calculate the horizontal velocity, you're always going to use the horizontal distance. Okay, and same as the likewise, when you want to find the vertical displacement, you're going to use vertical velocity only. Vertical displacement means height. Height is a vertical displacement. And if you are asked to calculate this height, which is 60 meter, you cannot use the vertical velocity. Okay, you know, but you have to use the vertical velocity. You cannot use the horizontal velocity. Horizontal velocity is only there to find horizontal distance. And same is the case, horizontal distance can only be used to find horizontal velocity. To find this distance, you're going to use all horizontal components of velocity. And to find this distance, you are always going to use the vertical components of velocity. Because velocity to overall आपके पास इस direction में, this is the resultant. This is the resultant of velocity. To find the height, you're going to use what? If this is the angle, you're going to use V sine theta for finding the height. And for finding the horizontal distance, you use horizontal component of velocity, which is V cos theta. So let's see another example and let's talk about vertical throws as well. Imagine throwing a ball to a friend and the ball goes up as well as forwards as well. One common idea in these calculations is that an object thrown with a vertical upwards component of motion will have a similar symmetrical trajectory, and at the highest point the vertical velocity is momentarily zero. Highest point पे हमेशा vertical velocity change करती रहेगी, but the vertical velocity is always going to be changing. यहाँ पे इट्स गोना बी लेसर, फिर यहाँ पे फिर आहिस्ते से कम होगी कम होगी कम होगी, यहाँ जीरो होगी, देन एज इट कम्स डाउन अगेन इट्स गोना कीप इंक्रीजिंग एंड इंक्रीजिंग. बट जो आपके पास हॉरिजॉन्टल वेलोसिटी है ना, इट्स साइज इज ऑलवेज गोइंग टू रिमेन सेम, कांस्टेंट, कांस्टेंट साइज. बट यू कैन सी दैट वर्टिकल वेलोसिटी, ठीक है, हॉरिजॉन्टल का वही है, बट वर्टिकल वेलोसिटी साइज is actually increasing as it comes down the trajectory path. So consider a second question. First, uniform acceleration under gravity means a is equal to minus 9.81, and the kinematics equation that can be used अगर आपको time नहीं दिया हुआ question के अंदर and you have to find s and you are given u and v, you can use this equation of motion. All things are the same. You are going to use the same formulas. There are no new formulas. The only thing that you have to care about is that what are you finding? Now, this is the height s. Now for height s, which velocity you have to use? The resultant velocity, the horizontal velocity, or the vertical velocity? Let's say the velocity resultant is 8 and the angle is 40 degree. So vertical, तो horizontal velocity क्या हो जाएगी? 8 cos 40 और vertical velocity हो जाएगी 8 sin 40. So when you're finding the height, you're going to use which velocity? The vertical velocity over here. This is the thing that you have to keep in mind. But when you're finding the time, you can use both. ठीक है, टाइम डजेंट मैटर क्योंकि टाइम तो उतना ही लगना है, हॉरिजॉन्टल वेलोसिटी हो या वर्टिकल वेलोसिटी हो, टाइम तो रिजल्टेंट ही पहुंचे. सो फॉर फाइंडिंग द टाइम यू कैन यूज एनी components of whatever velocity you want. So projectile is a moving object on which only force of significance acting is actually the gravity. The trajectory is thus predetermined by its initial velocity. And that is the end of your topic number one. You can complete the questions and then you can send me as well.